let's practice sketching a polynomial from everything we've learned so far. So we're given a polynomial right here. I need to start by finding the end behavior. So if you remember from the previous video, that means I need the degree and the leading coefficient. Now, something to know. That degree and leading coefficient is a little harder to find in this, what we call factored form, than when it's all multiplied out, which is called standard form. Now, I said it's a little harder, but not impossible. In factored form, here's what we're going to do. And by the way, I'm going to change this to a 36 for our problem. Okay. If I want to find the degree, I need the biggest exponent. But that only works when it's all multiplied out. So I'm going to pretend to multiply it all out. I don't have to do all of it because I only need to know what the biggest exponent is. So if I think about this part right here, x plus 3 squared, what is the biggest exponent I'm going to get from x plus 3 squared? Well, that's an x squared. I'm not going to get anything bigger. I'm not going to get an x cubed from that. I'm not going to get an x to the 4th. The biggest I'm going to get is an x squared. Then I'm going to times, because these are times together. The biggest exponent I'm going to get from here is, again, an x squared. Now, if I multiply these biggest exponents together, x squared times x squared gives me x to the 4th. Now I can find my degree, which is 4, or even, and my leading coefficient, which is a sneaky 1, which is positive. So this is going to be a positive even, which is going to be a smiley face. And now I can write out my end behavior statements. With a positive even, both are going to go up to positive infinity. Now, I'm going to be sketching this graph. So the way that I sketch end behavior is circling the two corners that match with my smiley face. Both up, both up. And that's end behavior. Now let's do zeros and multiplicity. So for zeros, that's where we set each factor equal to 0. So this first one is pretty easy, minus 3, I get x equals negative 3. This one I'm going to have to factor out, like our last chapter skills. So I'm going to need a number that multiplies to negative 36 and adds to 0. So numbers that multiply to negative 36 and adds to 0 would be a negative 6 and a positive 6. So I've got x minus 6, x plus 6. And now I set each of these ones equal to 0 and solve. Now let's list their multiplicity, which remember is how many times they occur in the equation. So this first one, x plus 3, that's going to occur twice. So that's going to have a multiplicity of 2. This next one, x minus 6, that's only going to occur once. And then the x plus 6 only occurs once. So x, this one is going to bounce, and these are both going to cross. Now, here's how we graph these. I'm going to take each of these zeros, negative 3, positive 6, negative 6, and I'm going to graph them. So I have negative 3, positive 6, negative 6. And I'm going to put a little c or a little b next to it, whether it bounces or crosses. So the negative 3 bounces, so it gets a b. The positive 6 crosses, so it gets a c. And the negative 6 crosses, so it gets a c. And now I'm actually ready to graph my function. So first off, my ends should point at my end behaviors, at my circles. Now I'm going to bring my graph up to my first intercept. I'm going to cross through that intercept because it's a C. Now I'm going to bring it up to the next one. I'm going to bounce off of this one because it's a B, and then bring it to the last one. I'm going to cross through that one since it's a C, and notice that we match up with the last end behavior. If you've done everything right, you should match up with your end behavior at the end. And that's our sketch of the graph. We're done. Okay, in the next video, we'll do example number 4 together.